Hello fellow chemists, in this video we're going to take a look at molar mass calculations. This video is labeled as intermediate because it assumes you have a basic understanding of the mole, Avogadro's number, and molar masses. If you need to review those topics, I'll put a link in the upper right hand corner. So now that we have talked a little bit about Avogadro's number, 6.022 times 10 to the 23rd, and we know that we can use that to convert from atoms into moles, and then we've also taken a look at atomic masses, and we've seen that the atomic masses on the periodic table can actually be given in units of grams per mole and used to convert back and forth between grams of atoms or molecules and moles of atoms or molecules. Let's take a look at a couple calculations that are using these terms. Now on the top part of the screen, I have an extremely useful conversion chart up here that I would recommend everybody gets familiar with and learns. And it shows you in 3 simple steps how to convert from atoms and molecules to get to moles, and then how to get to grams. So if you have grams and you want to get to moles, you're either going to be multiplying by or dividing by the atomic mass or formula mass if it's a molecule. And if you have atoms or moles or molecules and you want to get to moles, you're either going to be dividing by or multiplying by Avogadro's number. So while we're doing these problems, we'll kind of check with this chart and make sure that the chart is telling us to do the correct thing. So the first problem that we have says that if you have 27.8 grams of fluorine atoms, how many moles of fluorine do you have? So we're going to write on the right-hand side what we're looking for. We're looking for moles of fluorine. And it says we have 27.8 grams of fluorine. And then we're going to convert from grams to moles. Now this chart up here says when you're going from grams to moles, you should be dividing by the atomic mass. Well, let's see if that happens. So we'll set this up using the factor label method. Put grams on the bottom so that it cancels out, and moles on the top. And fluorine, if you look on the periodic table, has an atomic mass of 18.998, and that's grams per mole. So we have it set up so that grams and grams are diagonal, so they will cancel out. And when we do this, you can see that you are taking the mass, the grams, and you're dividing by the atomic mass. And that's exactly what the chart says. You should go grams, then divide by the atomic mass, and that should get you to moles. So when we actually do this, we take 27.8 times 1 and divide it by 18.998. That gives us 1.46 moles of fluorine. And that would be the answer to that one there. So now, if we take a look at another problem, this one's going to be going in reverse. We're going to start with moles and go to grams. And it's going to be a little bit more complicated because instead of giving us an individual atom, it's going to have us go from moles to grams using a molecule. So the second problem says, if you have 5.6 moles of CH4, how many grams of CH4 do you have? So we're being asked to find grams of CH4. Now, CH4 is a molecule that is made of 5 atoms, 4 hydrogens and 1 carbon. So we're going to first need to find the formula mass or the molecular mass for CH4. So CH4 is methane. And in methane, we have a carbon atom. And carbon, if you look on the periodic table, weighs 12.01 grams per mole. And in this molecule, there's only 1 carbon, so we'll multiply that by 1. So carbon will contribute 12.01 to the overall molecular mass of methane. Then we also have hydrogens, and each hydrogen weighs 1.01 grams per mole. And we have 4 of them. So that will lead to a total contribution of 4.04 to the overall molecular mass. And if we add these two together, we get a formula mass or a molecular mass of 16.05 grams per mole. Right, so we're told that we're starting with 5.6 moles of CH4, so 5.6 moles of CH4. And now we have our molecular mass or our formula mass that we can use to convert from moles to grams. We want moles to cancel out, so we'll put moles on the bottom. And we want to end up with grams, so we'll put grams up on the top. And our formula mass is 16.05 grams per mole per 1 mole. So now we have it set up so that moles and moles cancels out. So now we're going to be multiplying moles by the atomic mass to get to grams. All right, well, we're starting with moles, and the chart says to multiply by atomic mass to get to grams. So it's exactly what the factor label method tells us to do, so that's good. And when we multiply 5.6 by 16.05, we get 89.88 grams of CH4. So you can see that that chart up there does work. It's very useful. I use it all the time, so I would recommend that you get comfortable with using this. In the next video, we're going to take a look at a little bit more advanced problems where we go maybe from atoms to moles, or atoms to grams, or grams to molecules. So they're going to be multi-step problems. All right, that's it for this video. I hope you learned something, and I will see you in the next lesson.